what I have now is I have an animation editor. So if I just refresh the page here, you can see that this is a, here, let's, what is it? Okay. So if you're looking at the screen now, what you can see is an advanced GANI editor, GANI file editor. So this can edit and load animations. If you look in the sidebar here, this is very similar to the same level editor GUI that you saw in the previous video. It's the same application. What I did was I made it so that you can port in multiple different applications into the same engine. And so this can morph into a level editor. It can morph into a GANI editor, and you can also toggle that off and just play with the game itself. So the JEST engine is able to open these applications that you create just at the toggle of some lines of code. Or, you know, in a future edition, there could be the ability to just have a little dock down here with icons, and you can click the icons as you've seen in some of my other videos I was kind of playing with, and that would just open up the application. So this is the GANI editor. In the sidebar, you've got the animation menu, and this has a loop, and this means that if it's on, the animation is going to loop when it is playing in the game. And the same thing with this scrapbook here. This is very intuitive. You've seen this stuff kind of before in the GANI editor and Graal. You can create sprite groups and you can create sprites. So the sprite group, you can set an image. See that little image path field? And that links right to your web server where you can type in a path to an image. And that path to the image, which is a subfolder, is going to be loaded into the application. You can view the image, you can play with it, and cut it up, chop it up, and you'll have the different sprites that are going to be derived from that image set, which is part of the sprite group. And then down here, you can create stickers, which are nothing more than just instances, reference instances of sprites. So you can have the same sprite in the same scene multiple times, and you can edit your X and Y and Z value of each of the sprites that are part of your animation. You can add new frames, you can add new layers, subtract them, and you can scroll through your frames. So I'm just going to go ahead and open a file so you can kind of just see how this works. So if I open up this sword GANI file, you can see that it loaded up all the images separately. They loaded in piece by piece. I can go through my sprite groups or my sprites, and I can look at each of the parts. So my sprite groups, you can see I can see sprites, and this shows me the image that sets for sprites. And on my web server, it's in the subfolder path of sprites/sprites1.png. And it is obviously labeled sprites. And so you can edit that. You can create a new group, or if you modify this and just, do anything different, you can apply that change to it and rename it. You can go through your sprites, and the sprites, again, are attached to the groups. So this shadow is derived from the sprite group, and you can see it's nothing more than just a little piece of that image at 0, 0, 24 pixels wide, 12 pixels high, which gives us that little shadow right there that you can see. I know it's very hard to see it because it's like this very light charcoal gray on black, but it's there. And I can show you some other assets that are cut up from the sprite sheets. So you've got like your hat up or your head right view, and you can see this is the dimensions of it and where it's located on the sprite sheet. This is part of the sprite group, which is head. And so if you go into your groups, again, you can just go back and refer to what that is. And this is the default head, and that's the path to it that was set. So down here in your stickers, you can go through the different frames. And if you're looking through the different frames, you can scroll through. You see how I'm like toggling through the different frames. You can see the little sword slashing. So each of the parts of the animation are being split up, and they are allocated as each of these stickers, which are references to each sprite, and they are located in each of the different frames. You can even scroll through the different directions because they're located in separate layers. And so by changing the layer, you can see the character turn around, but that's all part of the same frame. So anyways, as you flip through the different layers in the frame, you can see the different sprite references. So if I'm looking at the shadow here, I can just change the X position by dragging the slider. Do you see that? Or I can just hit the the subtract and add button here. I can also edit that number directly. So if I just typed in 0 there, you can see it kind of pushes closer back to the player right at the 0 axis. It is aligned to that line. If I take the X and move it forward, you can kind of center it there back to where it was. I think it might have been at 14. I don't know. But anyways, you can also change the Y. And if you wanted it to be in the middle of the player there and you wanted it to overlap everything, you can just drag that Z coordinate right up to 5, and now it's overlapping the player. Sorry, I'm about to sneeze. Anyways, so that does everything that it needs to do. And then if you wanted to, after editing your player or your GANI files, your animations for whatever you're creating, you can just hit save as, and that downloads it, and now you've got it on your computer. So this is being done in the same software, which is JavaScript. It's this new, JavaScript engine that I've created. And that can be ported into Electron. And as everybody knows, you can run Electron on mobile platforms as well. So depending on how you compile it, you can take JavaScript and you can port it into iPhones. You can port it into Android Galaxies. You can port it basically anywhere. You can run it through your browser. You can run it through your desktop through Electron. You can just compile Electron and it'll run on Windows. It will run on Mac. Very easy, all using the same engine. So you are good to freaking go. And banging yes, you can absolutely load it up in your browser. And because it's loaded up in your browser, you can take all of that data and that is connected to your web server. So I had levels that were like syncing to the cloud on my level editor. And you can implement all of this data into a cloud situation where users can log in. There is a login system in the game engine now where you can create accounts, and that is being tied into a very, very small, lightweight PHP primitive quote-unquote CMS, a new quote-unquote PHP CMS, or a PHP CMS of your own if you wanted to. Basically, you can plug it into your database and have it drop and create accounts in a database system, even if that's attached to, I don't know if it was like a vBulletin board or some type of other website where there's accounts that you have downloaded the software for and licensed it. You can use that database to cross-pollinate with this and have your accounts created here or have them log in from there and have that data attached to that information in your MySQL database. And so all of this game information could be, just ported into the browser. You can pull it up anywhere in the world on any computer. You don't have to install anything if you're doing it through the browser. You can even pull it up on mobile devices, and you can do all kinds of stuff with that. You can even download it and put it into a MAMP or LAMP situation, which is going to be like a local host, and you can run it from there. Hot as fuck, hot off the presses, whatever you want it to be. However, I'm not going to stop there because as much as the JavaScript engine that I have here, the JEST JavaScript engine is super, super dope and rolling and working in the ways that it needs to work. And I can port this up in Electron and run it as a separate application. I can send that executable file out or that app file out to Mac devices, and I can run that virtually anywhere. Electron is so portable, you don't even know. So is JavaScript. I also want it to be super, super secure. So what I've done is I have created the general formats of how the engine works in JavaScript in C++ also. So one of the things that I've been working on recently is I completely and very heavily revamped a lot of the way that the files were being loaded. Before it was a little complicated. Now it's very, very streamlined. You just pass in an address, it loads it, it stores it, and it files it away in a way that's super, super organized. If you want to pull it back up, you just call it by its subdirectory and its file name, and it pulls it back out. So I don't have to have all of this stuff kind of organized by type. I don't have to have it organized by like gallery categories and all that stuff. before it was very, very complicated. I went through and I revamped it. The file system's so much cleaner, so much simpler, so much more modular, so much more flexible, so much more professional, easy to edit, and definitely better to maintain or fix bugs or enhance if you wanted to. In the C++, it was kind of weighing on me. I know that's kind of just me talking out here, but it's very important for you to understand. So the C++ is so much better than it was. And it is very similar now to the JavaScript. I mean, it was similar in the beginning as well, but the JavaScript went under heavy renovation while I was working on the animation editor that you're looking at here. And I went and I updated the C++, and it actually didn't take as long as I thought it would. And I got that running, and I went ahead and I included a light, very, very light primitive class called the inspector. So you can have an inspector open up in the game application for C++, and that will allow you to view things like anchors, the graphical representation of the anchors and the on-wall blocks if you wanted to. You can create this kind of debugging environment within the C++ if you wanted to, because the base class for it is there. And so it's basically whatever you want your debugger to be. It's not that more, much more work to implement because I already have the foundation for it in the C++ now. So now anyways, going back to the C++, what I wanted to do also was revamp the player system so that it's split up into different classes so that, the user is a child of, let's say, the player class, and the player is a child of the human class, and the human is a child of the worldling class, and the worldling class allows the animation central loop to process all of the worldlings under one for iterator. And the reason for that is so that we can have everything centralized. And so the player is now centralized in that loop, which is going to boom, 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 open up the door for implementing the online mode. So I've already got the WebSocket class kind of going for C++. I just haven't tested it out or worked it out or confirmed it's working. I just started converting the JavaScript over into C++. And so that's original online mode that I have for the JavaScript JEST engine is now also mostly ported over in C++. I just haven't done it yet. But anyways, the foundation for working with that it was kind of also weighing on me, and I got that done. So now it's very much at a place now where if you wanted to implement an online mode in the C++ engine, boom, you're pretty much good to go because the system is now designed around that. It's so much better. And check it out. I got onwall working as well. So now there is onwall detection, and the player walks around the world. It is now pulling in tile definitions and pushing that into the tile set in a way that is being parsed and organized, and quick accessor methods. You can just pull into the level and say, hey, what's this tile type from the level itself, and then that'll tell you exactly the tile type. You can run that through the worldlings on-wall system, and you can have the user class moving around and testing for on-wall before it makes a move. So anyway, let's just go ahead and show that to you guys. I have here a example of it. So I'm just going to port it up because I've already compiled it. I've been working in Ninja. I don't know if you guys know what Ninja is, but damn, it's fast and so beautiful. So I've been compiling with Ninja. This is, I think, using C++ 17 binaries for the the compiler, but I also think that too, this has already been pre-compiled. So I'm just going to go ahead and run this fucker, and it should open up, and we should be able to take a look at it. And I'm going to give you guys just a quick preview. It's, as you can see, he's walking around, and as he's touching the different walls and stuff, you can see he is moving into where he needs to be, and the walls are detecting and all that jazz. So anyways, yeah, it's basically working. I just got to work out how to optimize it better, but the engine's, partially working, which is very, very good, because that means that what we're able to then do is kind of start this new game development community where people are able to launch their game using C++ platforms, and they can enhance it and customize their engine, especially if I go open source. And so they can enhance that, and they can modify the engine in JavaScript. They can enhance the applications, including the animation editor, the level editor. They can fucking optimize the hell out of that, and they can edit it, and they don't have to compile it, and they don't have to do all that stuff, but that you have to do in C++. But there's also the C++ engine that they can mess around with, which is super, super dope. So being able to use your C++ engine to also launch the same game and not just have everything done in JavaScript and Electron means that your game would be completely portable all across the board, and it's all in the same content management system. So basically, the way that it runs is very similar. So if you build your game in JavaScript and then you build it in C++, it's very much built the same because it's the same content management system just written in a different language. And so it's the same content management system design, the same game engine design, just done in 2 different languages. So anyways, you would definitely be super, super, empowered to be able to do whatever it is that you're looking to do. And these tools are there, and you can make your games in C++, you can make your games in JavaScript, you can make your games in pretty much anything. What I'm going to go ahead and do is I'm just going to hop off this video. But coming along here, you don't really, who needs Unixmad? Who needs these other people? It's time to get away from these Generation X boomer psychopaths who violate kids and steal our lives, who steal our work, who lie about it, and enrich themselves and try to push us to suicide and try to push us to killing each other and trying to wave stolen power that they steal from us in front of kids' face in order to turn the children against their victims, by bribing them with power and running around playing a victim while they haven't done anything. Unixmad's not a game creator. He just stole everything. So now we've got our own engines. We've got our own level editors. We've got our own software. We can create our own file structures. We can create our own game worlds. We can do it in C++. We can do it in Electron. We can do it in JavaScript. We can have it mobile. We can have it on any platform. We can launch it on multiple devices, and also, like I said, in different formats. So you can do it in JavaScript, but also C++, which gives you added security. If you wanted to take that C++ and compile it for any operating system or even for mobile devices, it wouldn't be too complicated, because having access to the code written from the ground up and also having access to the code written from the ground up for the JavaScript means that you're not going to use somebody else's external login system to try to create your stuff anymore. Like with Graal, you don't have access to the backend. You don't have access to the compiler. You don't have access to the engine. You don't have a license to use the backend code. You don't have a license to modify the backend code, to modify the way that it gets ported and the way that the GUI is created. You don't have access to the coding the server and modifying the server. Everything is closed off, and they did that because they were robbing people. They were robbing children specifically, and they didn't want to give anybody access to the backend code, because if they had total control over the way that that content was being experienced and ported, then nobody would be able to stop them as long as they stayed over in foreign countries and just lied and abused and bribed people with stolen power and money. So by having access to the back end of all of these content management systems and being able to do all this stuff yourself without anybody else's approval or power or needs, you are going to be basically liberated from Unixmad. You can do whatever you want now. You can be free. You can make your games again. You can start to just customize the game world on every level and not just trying to work within the confines of that stupid Graal engine that is a lie. By the way, it's a lie to begin with, because it was built and predicated on child predation, and the code's not that great, but also, everybody wants to have access to the backend code, and it should be open source. And so, I'd like to go open source, but, I need to have tons of, a lot of more support before I do that. But just so you guys know, we're at a place now where if you wanted to basically replace Unixmad and get rid of him and be the master of your own game world, I've got the JEST engine that is done in C++ and JavaScript, and the JavaScript one lets you create your levels, your animations. You can also play the game in JavaScript. It has an online mode. You can play your friends in it. and you can edit the back end and make it do whatever you want. You can customize it. You can customize the map. You can customize the pause menu. You can customize everything without having to use GScript. You can just customize it from the ground up and optimize it. You can port it again to anything you wanted to, but you can then go ahead and do it in C++ all over again as well, and really, really, fine tune and compile your game and have absolute total control over absolutely everything, every aspect of it, and simplify it and clean it up and gut things out that you don't want and that you don't need. But yeah, so, I just wanted to drop this video, let you guys know, let you guys take a preview. This is Antago signing out. Thanks for tuning in. Have a good day and happy 2026.